Okay, hello. So today I would like to explain how did I get my answers for question number 10. So let me read the question first. The square deforms into the position shown by the dashed lines. Determine the average normal strain along each diagonal AB and CD. Side D prime and B prime remains horizontal. So as you can see here, it is a square, by which means the width and the length are equal measurement, which is 50 millimeter. So you can say that the length of AB and DC are equal by using the Pythagoras theorem method. So the values that I got is 70.71 millimeter for AB and DC respectively. After we have found the diagonal lengths of original shape, now we can proceed to find D prime, C prime, and AB prime. So at here, the part 1, in the first hand, I can find D prime and C prime first. So I use the cosine's law method in order to find the diagonal lengths of D prime and D prime C prime. So the formula is D prime C prime squared equals to AD prime squared plus AC prime squared. This one got left out. Minus 2 times with AD prime times with AC prime cos D prime C prime. So what is the angle of D prime C prime actually? The angles of D prime C prime is always opposite or contradicting with the diagonal length that we want to find. For an example, we want to find the length of D prime and C prime. So the angles that are suitable to put here is opposite the diagonal length of D prime and C prime, which is 91.5 degrees. So substitute all the values and square root after you finish plus, times, minus, and all. The final value is 79.59 millimeter. Here it is said that side D prime B prime remains horizontal, which means it is not tilted, or which means the angle are shifted around here. Shifted around here. No. So here we need to find 50 minus 3, which means the original length. The original length here is 50, and then the B prime here has been shifted to the left as much as 3 millimeter. And then in order to find how far does D prime goes away from the original D, is by using the sine method, sine theta method. Yeah. So sine 1.5, as you can see here, the original angle is 90 and has been increased as much as 1.5 degrees. So we only want to find D prime length here. How far does D prime has been shifted or moved or increased after the deformation. So we use the increase in angle as much as 1.5 degrees equals to opposite line, which is the D prime, over hypotenuse, which is the 53 millimeter here. So we already have the angle, and then we also already have the hypotenuse. So we move the hypotenuse up here in order to find opposite line. The opposite line is the D prime. This one. Yeah. So we used after we got the 53 sine 1.5 degrees, we plus it with 50 minus 3, which is the B prime measurement, and then we got 48.39 millimeter. After that, we go to the second triangle, which is AB prime here. Okay, AB prime. Now the same method also, by using cosine's law, I got the AB prime value by using cosine's law. AB prime squared equals to B prime d prime squared plus d prime a squared minus with 2 b prime d prime and d prime a cos with a b prime. This cos a b prime also the same about the angle just now. It is contradicting or opposite with the diagonal length that we want to find, which is a b prime. So how did I get at the 8.5 here? So here you can see the triangle of d prime a c prime. The angle at A is 91.5, so 180 minus 91.5, you can get wait for a minute, let me check, minus 91.5 because I forgot the value and I didn't write it there. So here after you minus 180 minus with 91.5 and then divide by 2, you will get 44.25 each here and also here it is 44.25 degrees. So as we have learned in school with mathematics, the angle here is equal with the angle at here. Yeah, I think it's corresponding angle if not mistaken. And then so since it is the same angle as this one, I mean the value, so it's kind of like twice the angle here. So 44.25 times 2 equals to 88.5. So the angle here will be substituted into here, okay, cos AB prime. So after we substitute all the measurement here, the values, and we all get 70.83 millimeter. Then after that, we can find the average normal strain by using the formula of the final length minus with original length over original length, okay, based on my understanding. So yeah, for the normal strain of AB, it is 0.0017 millimeter over millimeter, which is dimensionless, and also for DC is 0.1256 millimeter over millimeter, which is also dimensionless. So that's the answer for my question. And yeah, thank you. This is Dorothy. Check out. Bye.